Now, let me finish this thing out first. So what we have here, just I have told you before it connection went out, that we are keeping the same, we are using the same indenter, and we are using the same load here. And if we get higher size of the depression itself, like 5.46 here or 5.91 here, or the same for this type of pole itself, we can be certain that it is with uh, it is going with, we are testing the softer material itself, and smaller the size of the indenter like this, and smaller the size of the intent, there's 5 millimeter ball for 10 millimeter ball. So if size is around 2.54 or 2.6 like this, 2.60 means this is harder ball, and we are having the hardness of 556 Brenner hardness, or here if we have the diameter 3.05, we'll have comparatively less hardness, that is, but still higher, that is 4.401 Brenner hardness itself. This is the method of, this is the first method of designing the Brenner hardness test. So the method of Brenner hardness test is like this. First, select the material, the workpiece which we want to test. Next, from the available chart, of the machine, from the machine, select the indenter, (10mm) or 5mm steel ball. Next, then select the load of indentation, This load is available from the chart given by the machine manufacturer. Let's see load activity load. Load actuating load. Rod in horizontal, and left position, position. Clean the workpiece or test piece thoroughly, and clean the table holding table thoroughly. Then place the block workpiece on the table by using the screw jack under the table or the screw jack under the table and lift the table with the what? Table with the job workpiece until it touch this the indenter. Then apply power, then applied the specified load on load carrying hanger apply the load by rotating actuating rod clockwise until it stops. Then with this sentence position, keep in this position, wait for 10 to 20 seconds and then is the load. Take the workpiece from the machine and measure the diameter of impression by the brilliant microscope. Tally the diameter of impression with the size of indenter and applied load. Find out from the Fresnel hardness chart. The required Fresnel hardness. Let us go to few charts. So loadings are there.
This is our Fresnel hardness testing machine. It is kept over a table, and over the table along with the machine we have our microscope, test workpieces. This is our Fresnel hardness testing machine. It is kept over a table. This is our Fresnel hardness testing machine. It is kept over a table, and over the table along with the machine we have our microscope, test workpieces, and the indenter itself kept side by side. In the table, this is our Fresnel hardness testing machine. It is kept over a table, and over the table along with the machine we have our microscope, test workpieces, and the indenter itself kept side by side. In the table, in the machine, we have a load lifting platform like here, a indenter holding device, and a load actuating rod, which will load the load when rotated clockwise and unload the load when rotated anti-clockwise. The load is kept or fixed on the platform or hanger like this, over which a load of up to 3000 equivalent weight, 3000 kgf or 3 metric ton can be loaded. And we have the loads as kept on the floor. We have 6 different weights. Of each of them are equivalent, 4 of them are equivalent to 5 kgf weight, and 2 of them are equivalent to 50 kgf weight. This can be loaded over this load actuating over this hanger, one at a time, one all at a time according to the requirement of our job. This machine is defined and known as Fresnel hardness testing machine. Here an aluminium workpiece is kept above the loading and unloading platform, and it is here an aluminium workpiece is kept above the loading and unloading platform, and it is and a 10 millimeter indenter is fixed over the indenter fixing device. The aluminum the table is raised by rotating the handles clockwise and anti-clockwise to lift it so that the workpiece engaged in the indenter itself. Next, load actuating rod is kept on the left side, and you have to move it clockwise to engage the load itself. And on the hanger, a 250 kg weight is fixed, as the hanger itself can produce 500 kg equivalent weight. Totally, we can engage 750 kg of equivalent weight, which is good for making the impression of the aluminum itself. Now I am creating the impression by moving the load actuating rod clockwise in the position so that it engages the indenter to the workpiece, and kept it as it is for more or less 5 to 10 seconds, and then actually unloading the indenter and total lifting device is brought downwards here so that the impression created can be visible over it, which is here. This diameter of this impression can be measured by means of the microscope itself, which with an accuracy of 0.01 plus minus 0.01 millimeter.
Today I am conducting the experiment of Brinell hardness number. This is the experiment. Now this is the tableau column. We have to find out the Brinell hardness number for ferrous material 187.5, major diameter 250 mm, minor diameter for non-ferrous material. These are the major diameter for the ferrous and non-ferrous. The indenter will be 2.5 mm, 5 mm. This is the tableau column. This is the ferrous material, mild steel, cast iron. The indenter used is 2.5 mm diameter indenter. This is the 2.5 mm diameter indenter we are going to use. For non-ferrous material, this is the non-ferrous material. We are using the 5 mm indenter diameter. Now, this is the platform. For ferrous material, we have to fix 187.5 kg and fix the indenter here with the help of Allen key. With the help of Allen key, you have to fix here. Now indenter is fixed here. Cast iron is placed over the platform. With the help of elevating screw, rotate clockwise direction such that the specimen touches to the indenter. As it touches to the indenter, we have to apply the minor load 3 kg. A small needle moves anti-clockwise direction 3 kg and larger needle moves 0. Small 3 kg, larger will be 0. Now apply the load. The larger needle will moving in anti-clockwise direction. Okay, as the larger needle stops, you have to wait for 1 minute in case of Brinell hardness number. In case of Rockwell hardness number, you have to wait for 30 seconds. Wait for 1 minute, then unload it. Unloading should be slowly. You have to carry it out. Go for next trial. Because here we are using microscope in order to find out the indented diameter. Go for next position. After getting the indentation with the help of a chalk piece, you have to mark over the indent. This is the part. This is the indenter. This is the indentation. This is the indentation. I have done it. Again, I will do for second indentation. I will place over the platform. Apply 3 kg minor load. Load is applied. This is the second trial. We are performing it. As the larger needle stops, wait for 1 minute. Wait for 1 minute. Next, unload it. Move the anti-clockwise rotation. Remove the specimen from the platform. Go for marking here. Go for other color chalk piece in order to get. This is the indenter here. There are two indenters, this and this. Next, I will go for third indentation. Place over the platform. Rotate it. 3 kg minor load is applied. Load is applied here. As the larger noodle is moving in anti-clockwise direction, I am performing in a faster way, but in exam you have to wait for 1 minute so that the material enter into the plastic region. Now wait for 1 minute. Now unload it. Unload it. Anti-clockwise rotation. Now mark the specimen with the help of other chalk piece. The 3 indentations. This one more is here, one more is here, one more is here. Now, with the help of this microscope, place over the specimen. That part here. Now there is a marking over here. Count the line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means the first indentation is 10. 10 is nothing but 1.0 you have to write. The second reading is again count the line, it is 11. 11 means you have to write 1.1. I will go for third reading. It is 1.1. 11 is nothing but you have to consider 1.1. Consider 1.1. In this way you have to perform the test. I have considered the ferrous cast iron. From the microscope, this is the microscope you have to find out, and after getting this value, go for mean and substitute in the formula. In case of ferrous material, please change the value. Load 250 and indenter will be 5 mm and it has to be fixed here, and you have to repeat the procedure. Same procedure you have to repeat. After taking the readings over that of the specimen, this is the specimen, aluminum and brass, and you have to check into the microscope. The same procedure you have to repeat. You have to wait for 1 minute here.